We can get a bucket of water if you're tempted to get water into the podcast.
Welcome to Ascend Your Story, where we talk to people in science, tech and research from the Ascent Media studio in the sunniest place on earth, Sunshine, in Melbourne's west, on the lands of the Wurundjeri people. I'm Sam O'Reilly, the director at Ascent Media. Today's guest is a born tinkerer. He spent a decade in the media industry before launching a digital agency called Sequence Digital with a close friend, where they focus on crafting bespoke workflow software. Then, somewhere in the fog of COVID lockdowns, they accidentally started an AgTech startup called Rhino Instruments. Based in Geelong, west of Melbourne, he has spent years developing this rugged solar-powered sensor unit that detects overheating in compost and gives early warning alerts to help prevent compost fires. Pat Blampied, welcome to Ascend Your Story.
Thanks for having me.
Pat, you grew up in the sunniest place on earth, in Sunshine, here in the west. And I believe you've actually been in the studio before.
It's a bit bizarre. This wasn't planned, this episode. I was just turning up to grab some milk and bread, but great, sure, let's go.
So for a long time before we moved in, this was a tofu factory. About 27 years, I've been told.
Yeah, right.
But before that, it was a milk bar. And as a young child, you came along here, didn't you?
Yes, I did. It's funny how small the world is.
Yeah.
So, I have memories of, we lived on the other side of the line, so we'd grab the BMX and go under the very scary underpass, which is now gone, thankfully, and ride down, see my friend Darren, and go to the milk bar, grab some lollies, go down to the river, ride the bikes, and sit and eat the lollies, and yeah.
That's awesome. Well, welcome back to your childhood milk bar.
Thank you. You filled it with things that I love now as well. So all the old computers and gaming consoles. It's very exciting.
We need to do an episode just on the old technology in the AV museum in the Ascent Media studio.
I'll bring the screwdrivers, rip them apart, and have a look inside.
Now, Pat, we've known each other for over 2 decades, and we worked in community radio together back in the early 2000s, and that was when I was hosting an 80s hip-hop radio show, not a serious podcast about science and technology that I am now. Now, after your stint in community radio, you moved to commercial radio in Geelong, and I'll never forget this story about... actually, I'm going to let you tell the story.
I've got to make sure I remember the story
See
now.
if you remember the story. And just next to me, for those just listening, not watching the video, I've got a blue tea towel over a unit that I'm about to expose for Pat to jog Pat's memory. But Pat, here is an old telephone, and do you know the story I'm thinking of?
I'm remembering Bluetooth.
Yes.
Yeah.
Yes. Tell me about your Bluetooth technology. This is early 2000s, so Bluetooth had only been around for a little while. We had them in car kits, phone units in cars.
Yes.
And you did a little conversion. Tell me about it.
Yes. So I had a bit of an obsession with taking apart old technology and at times putting new things in. And I was the guy that goes around town and, gives out the packs of chips and the icy cold cans of drink and all of that. So, sort of do the phone cross and, call in to the breakfast show and, say, hey, we're down here at, Eastern Beach in Geelong and we're giving away your X product 1, X product 2, X product 3, we'll be here for the next 10 minutes, come down and see us. And I just sort of thought, I guess mobiles were sort of new at the time, so it was cool that we could do that at all. But I just had this idea that, wouldn't it be fun if we had an old telephone that should look like it's connected to a wire, but it's wireless. So grabbed a Bluetooth car kit and sort of built it into the handset of the phone so that we could go around holding the dial phone and, I don't know how effective it was. People were just sort of like not sure if I was like, he's with the radio van, so he can't be too crazy. So I guess I can engage with the guy, but just not really understanding what was going on. So we used it a bit and then they told me maybe it should be retired. So we moved on from that experiment. But
It's the story I tell everyone when I talk about Pat Blampied.
it's good to be defined by the old telephone.
That and the Nintendo game controller belt buckle that you wore at your wedding.
Yes, beautiful belt buckle. Still have. I should have worn the belt buckle.
So we're going to talk about your unit, the Rhino Instruments unit, that helps alert people to prevent compost fires.
Yeah.
So since this show's inception, you've been top of my list to talk to, and everyone that I tell who's about who's coming on the show, who's coming up, eagerly wants to know more about compost fires, because the everyday person that doesn't know that compost fires are a thing. Like, it's not something. It's not a hot topic.
Or is it?
So you have children, right? You're a father.
They're loving it. They're still at the age where dad's jokes are great. So
awesome.
Yep.
So compost fires, are these happening in your neighbourhood backyard, or are these just commercial sized compost heaps?
Look, I mean, it maybe could happen in a backyard, but it's pretty unlikely. It's more when you pile up a lot of material. So what's sort of happening, which is part of the compost process, is you bring together your organic material, and it starts out as, it might be grass clippings and branches and, a bit of food or something like that, depending on, at a commercial plant, depending on what they're processing. And, you've got sort of a nitrogen carbon mix. That starts to heat up, and that's part of the breakdown process. In commercial composting, you're aiming for like 55 to 75 degrees so that you're pasteurizing the material and getting rid of the pathogens that are dangerous to human health, kind of like you do with milk. But then depending on what's in there and how mature it is and the weather conditions and, that mix of like a bit more grass will be a hotter mix, for example. You can get temperatures up above 90 degrees, and that's when you start to get worried. And being large stockpiles, which are the ones that we sort of deal with, you're talking about sort of, maybe 6 meters long and wide, 2, 3, maybe 4, maybe I've got my maths wrong, but quite big piles. So when you've got that much material and you start getting smoke or, combustion, you've got a big problem on your hand then. So you want to get on it early as possible. And people think they spontaneously combust, but if you've got a temperature probe that's 1.5 meters sort of in the pile, it's never actually spontaneous. It's sort of creeping, and then it'll either level off or it starts ramping pretty quickly. So just finding that right spot to act on it.
Mm. And is that called thermal runoff?
I mean, it could be a thermal runaway. I guess thermal runaway is the battery sort of phrase that they use. But yeah, I guess it does run away and then it catches on fire and then you got an issue on your hands. So, and it's not just in organics. I mean, there's been fires. There's a big SKM recycling plant that went up in Coolaroo a few years ago. And that's like, it started with sort of recycling, with bits of organic material in there, and it heated up. And then once it was ignited, my understanding is that like even the glass might have been feeding it and the plastics were feeding the fire. So you really want to keep those fires not happening if possible. Yeah.
So do you know how often these fires are happening?
Look, there's no national statistic that I'm aware of.
There's no compost fire hotline that you register your most recent compost fire?
No, I mean, the EPA keep a database of fires, but even EPA is obviously state-based, so there's different authorities around the country, and then you've got, CFA would deal with some of this stuff and that sort of thing. So my feeling is there's probably like 50 to 150 fires, and some of them are serious, some of them are not so serious. You only have to read go to the ABC website and you see there was a big one up in Cairns recently that went up. And when they do go up, they're disastrous, and it's not just the damage to the facility, but it's also like the runoff, talking about, I was listening to one of the earlier episodes that you did with, who was the one with the water quality? Brady, yeah. So that was a great episode. And, he was talking about water quality in creeks. Well, a lot of the contaminants that are in the creek, one of the sources is, firefighting. So, have a massive fire, it's near a sensitive wetland or a creek or a river, that runoff has to go somewhere, and, it ends up in our waterways. So, yeah.
So how many fires do you think your unit has prevented?
Look, we sort of, for compost stockpiles, we say sort of 90, 92 degrees, based on the feedback from the customers that are using the units. That's where they want to sort of start taking action. I couldn't tell you specifically how many, but I've probably seen 5 or 6 events in there where, there's been, some sort of action taken, I guess. And it's funny, I know the way I would have thought you'd deal with that is, well, you better sort of spread the material out. So, go over there and, start digging, or get a truck and sort of open up the pile. But it turns out that if you open up the pile without watering it first, you actually bring an inrush of oxygen. And you can imagine that actually can make the problem worse. So it's been really interesting, because we're, talking about being a tinkerer and starting an accidental compost, hardware company. We're learning from the customer as well. And so we talk to them and find out a lot of information, and I guess they have their processes and they evolve their processes as they make these discoveries, I guess.
Can you describe your unit to us?
Yeah. So, I mean, it's
Actually, why don't we grab the unit?
We're going to do that? Okay, we can grab the unit.
Grab it.
I'll just grab it. Yeah.
Pat has just walked across the room to grab his Rhino Instruments unit, and he's coming back to the couch. All right.
The audio description.
Yes, the audio
as well.
description. So Pat's holding a small orange box, probably the size of, what would you say, a Sega Game Gear from early 90s.
You can tell the 80s and 90s design influence, probably. There's a real sort of console feel to it. But I guess this is almost a product launch, because we haven't been out here publicly. We haven't shown this anywhere yet. And this is sort of the evolution of 3 versions that we've done. So this would be the 3rd sort of iteration.
It's a lot smaller than the one you've got on your website, that's for sure.
Yeah, so all the material has been with the RM1, which was sort of an evolution of a prototype that I built. This one is I guess the evolution of a couple of things. It's the evolution of everything we worked on, all the design flaws that I could see, and that the customer, we do a lot of sort of user-centric design and get a lot of feedback from them. And then also just the battery technology. We worked on a grant with Sustainability Victoria, and that through that we've sort of implemented the research that we did with them, and that's brought down the size and weight of the unit, which has been great. But this is the little unit. It is, like you say, about a ruler's length, couple of packs of cards thick, and it's solar powered, 1-button operation, which was important to the customer. You plug your sensor in to the back of it, switch it on, and then you go over to your computer and you open up a nice console that presents you with the data that you've collected really nicely, essentially. And it's got GPS, it's got a 4G modem, so there's no sort of Wi-Fi gateways or entering passwords or anything. It's just meant to be super straightforward, because with a lot of these sites, you've got contractors turning up to do the operations work. They may never have been to the site. They'll be briefed on do an OHS briefing on, how the site operates and what equipment's there and all of that. And then they're sort of in and out, but they'll have to, we like them to remove these before they work on the compost piles. Otherwise they get bent up and damaged, which has happened as well. So that's part of the robust nature of it. And the enclosure you're looking at too, the main enclosure is 3D printed stainless steel. So there's a few interesting technologies in there. Yeah.
And it's got an IP rating.
Yes, we can get a bucket of water if you're tempted to get water into the podcast.
Yeah, let's get that bucket of water in, and then we'll come back.
Okay, let's do that.
All right, so we're back. We now have a bucket of water in front of us, and you're going to show us this unit underwater.
Yes. So this is our a short version of our temperature probe. So this pipe can be, meter and a half, however long we want to
This
make
one's
it.
maybe 40 centimeters long, yeah?
Yes. I've learned not to walk through the centre of town into cafes when I'm having a meeting with someone with long bits of metal and stuff. It makes people nervous. So we built a little demo one. But,
Good idea.
you can imagine if you're on site, you just plug in, put the little lock on, and then you can switch it on. We don't recommend that you run it this way, operate the unit underwater. But what we found over the years is that, you get 80 mil of rain. It's like being underwater, right? So we've dealt with quite a few units that have been underwater and
Oh, he's dropped the whole unit underwater.
dropped the whole unit underwater.
And he's
then
turning it on, the
switch it
one
on.
button push.
You can see on the screen that it's loading the logo.
All right, let's have a quick squeeze.
And
Okay, there we go.
it's warm in here.
Yeah?
Yeah.
What temperature we got?
20, 21.
There we go.
And you can I'll sit there and warm it up a little,
Okay.
switch it back on and get a new reading out of it. There we go, 22.4 now. So
Well, we use a lot of underwater gear for our underwater shoots, and a lot of our gear is very much waterproof. I wonder if I could take that one down, and how deep would it go?
well, so we've certified to IP67, which is 30 minutes underwater at a meter deep.
Okay.
I'm confident enough we could take it probably a little bit further if we wanted to, but that's where we put it.
Probably not many compost heaps where I'm shooting underwater, but
No.
oh, that's pretty cool. It feels like it's very much over-engineered for the usual compost heap.
Absolutely, yes. Look, I think the first version that we built, so the way it all came about is we were already building or writing software for the one of the compost facilities that we work with, which in itself is sort of an interesting story. But they came to us they'd started fresh. They had a pasteurization area, they had a maturation area, and then as they were getting to the end of that process setting up, they're sort of starting to go, okay, well, the parkland that we're spreading this compost on, or the farms that we're taking this to, they're not quite ready for the materials, so we're going to need to stockpile it. And that's when the question came up, like, oh, now we're making these big piles up. We really probably should remote monitor them. Is there anything that you're aware of that does that? Because at that time, there's sort of no one there after 5. There's no one there on weekends. How can we get an early warning? And so we were sort of, mostly thinking like, oh, we'll find a product on the market and we'll just integrate it into our software and, use their early warning system or whatever. But we sort of couldn't find anything that was that combination of like light, easy to use, didn't have, gateway passwords. I mean, they didn't even have internet out there apart from cellular at the time. So that's sort of how it came about. But in building that first prototype, which was a dedicated temperature probe, I'm like, okay, well, we need to put holes in the box so we can put a switch and so that we can, actually plug in whatever we're plugging in. This is looking more and more like some form of computer that's really well waterproofed, but has the holes and can let the sun in for solar power, et cetera, et cetera. And that's where it sort of evolved into like, all right, this is the main application that we're using it in, but perhaps this has a broader application. Perhaps we can, connect different sensors because there's, tens of thousands of different sensors out there. And back to that water quality episode that I was listening to recently that you released, what I was hearing from him is that there's a gap. The science needs more data, and there's just so many opportunities to collect that data. And he was talking about, was Broden, was it? Brady, sorry. Brady. He was talking about, they've got the spectrometer and you need to get the samples and bring them in. And then there's other methods of getting little samples in between that they're thinking about. I just think there's a massive opportunity to fill that gap and to do the automated monitoring so that the people that then know what to do with the data and are looking for solutions. They have the data they need so that they can come up with those solutions. So that's sort of how it ended up, very over-engineered.
So at this point, what other probes could you put in and test for?
So we've had a VOC sensor on it, and we actually, someone we met just recently, they've asked us for sort of.
So you're going to have to explain VOC.
Sorry, volatile organic compounds.
Like, I mean, I knew, but the listeners.
The listener. We've got to think about the listener. Gee, if only I'd worked in radio and had thought about that sort of stuff before. Yes, so volatile organic compounds, things that it's probably most common in an indoor setting. There are limitations on the types of VOCs and the amount of VOCs that can be released out of a product like a carpet or a paint, because they build up in the environment. And they're generally damaging to human health in too higher concentrations. So we're sort of just playing with a sensor just to show the other application, and then we were showing this other potential. We're sort of looking at partnering with some environmental groups that do sort of remediation and that sort of thing, and just asking them about what they were interested in. And their big interest has been in detecting methane, which is, commonly sort of leached out of, old sites like old landfills and that sort of thing. And carbon monoxide is another one, which commonly you'd know that from, not running your car unless it's an EV inside your garage, because the gas that builds up that's really toxic, it's mostly carbon monoxide that's the concern. So detecting those two would be an obvious thing for us to be doing next.
So it's waterproof and it's solar powered. Why is solar power so important to you?
Look, I mean, just from the perspective of thinking about the user on the site, the less you have to think about with powering the device, the less you have to worry about whether it's actually charged up or running, that sort of thing. So having the user not having to think about, this is a unit that runs on batteries, but is the battery in a good state? Do we have spare units to take while we're charging it, or we have to change out batteries? There's sort of as a clean tech benefit to, I guess, not using just constant disposable batteries, that sort of thing, but just a load on the user of actually managing the power of these devices. Being that it has GPS in it, it does sort of that GPS chip uses a fair bit of power. So to be able to get regular location, you need to have a sizable enough battery in there, and it does draw down. So it just sort of made sense that if possible, we really just wanted them to be able to put it out there and then really just not think about it. And that's where a lot of the design decisions came from.
Now, it's a pretty solid looking box. I can't see a battery compartment. How would you change the batteries if they died?
Look, due to using lithium-ion batteries and the fact that they can be an expert user thing, you want to open it up by giving it to us and getting us to open it up. But look, on the back, we'll pull it out again. Still running, but. Have you accounted for a wet couch in your podcast from?
I'll get the towel
rag from the telephone to dry it out. Thank you.
There's a rag I prepared earlier.
Thank you. This is very, very well planned. So on the back, you've got your back panel there, and we can access everything. I guess I wanted to make it as repairable as possible. So in there, we haven't we need to, from a regulatory perspective, and I don't have the sticker on the back of this one, but make sure that the user's safety, is paramount. So getting them to change the battery is not what we want, but we don't want it so locked down that you can't get in there or we can't get in there and change it for you. We also get sort of information back on how the battery is going, so we can actually see when the battery is running down and not charging up enough, and kind of go, all right, that one's getting a little bit tired. Let's change it over, send it back, and we'll be able to get it back running for you. So we can open it up, we can fully strip it down, and pull out the cells and all that. But that's sort of how it works.
Tell me about the circuit boards, because you haven't gone with the mobile phone technology where it's broken, replace it. You've put in repairable parts in there.
Yeah, so as much as possible, and I guess as much as possible, we've tried to make it as repairable as possible. And I guess what I've discovered I'll just drop it back in the water now. Really. Sorry, Sam. I've
got water all over my face.
First for everything on this.
It's a wet podcast today.
So should have done the whole thing underwater. That would have been great. I wanted to make it as modular and repairable as possible. So even stuff like, the solar panels on it are they're on the PCB in a way that we can desolder them if we want and put on a new module. The older unit, which is the ones that might still be on, depending on when you're listening or watching this, might still be on our website. They were very modular, and I learnt a lot about I guess maybe look at the PC industry, right? People complain about soldered memory because you can't upgrade your memory anymore. But I can see from the company's perspective now that the failure rate of having soldered in memory would be so much lower. So you have less user problems and less issues with your devices overall. Mm-hmm. So potentially less get chucked out. So it's been really walking the balance of like not having every single piece removable, because they are subject to, a lot of vibration and movement, and, they get chucked on the ground and that sort of thing. So really trying to balance that so that they're as dismantleable as possible while still having a lot of stuff soldered to the board. But yeah, we're doing our own print PCB. I think I may have said that phrase, a printed circuit board. We're doing our own printed circuit board designs now. And so everything in there is custom. We've put it together ourselves. And one thing that we have left as removable is the 4G module, though, because, if recently the 3G network is shut down. And so, again, that kind of approach of like, there's one where you've got a module, the slot is really solid, we can put that in, and then down the track, if 4G will inevitably, one day, will be shut down and we'll have 5 and 6G or something like that. We wanted to leave it open that could potentially not be the end of these devices and, hey, you've got to buy a new one, but be able to, slot in a new modem and be able to keep them serviceable in field.
Some good future proofing there.
Yeah.
And you said you used a 3D printer, 3D metal printer.
3D metal printer.
Wow.
Should we pause and change the props, Sam?
Yeah, let's pause there.
Okay.
All right. So with the magic of editing, we're back, and we have in front of us looks like a box with a rhino on it. No, two boxes, one with a rhino on it. Tell me about it.
Yeah, so this one is a 3D printed plastic box, and this is the same box. I couldn't find the lid, unfortunately, but printed in stainless steel. So the first device that we put together, we sort of built it from just standard parts. Bought from like J-Car and that, little electronics store in Geelong around the country.
Jiffy boxes kind of things?
Jiffy boxes?
I think that's what they're called.
It might be,
They were back in my day.
They were back in your day. Well, your day was my day. But yeah, your standard sort of, a box with a seal and, and you can, if you're going back to putting holes in boxes and still keeping them waterproof, if you're going to manually drill a hole in a standard box, it's going to be different every time and there's going to be variation and all that. So the second version, we were in COVID lockdown, so we worked with an engineer locally to put the boxes together, and they were made of steel, but it was sort of box steel sections, and again wasn't particularly scalable as a potential product. But then started playing with the 3D printing, and the evolution of that technology and what it lets me do as, I guess, a born tinkerer. It just opens up something that wasn't available before. So you'd look at how would you enclose a computer as a tinkerer? Maybe you go speak to an injection molder, but then you have to pay for a mold, and then doing multiple iterations of that's going to get really expensive, and then really they're going to want an order of like 5, 10, 100,000 before they're going to do the job for you. So we were able to get a Bamboo Labs printer for, I think it was $1,800, something like that, and start prototyping our cases. So this was just this is really early on, me just playing with CAD software and actually drawing boxes and seeing what was possible, and sort of, coming up, can we actually, how do you do an overhang without it sort of collapsing in on itself and that sort of thing. And then started playing with the 3D printed metal as well. And I knew this was possible, and I'd sort of seen it online, but I feel like until you've sort of picked up the box and understood that it is like 3D printed steel it's a steel box, right?
Yeah,
like
it's a steel heavy box.
It's a heavy box, and you can see
the layers.
You can see the layers, but then on the bottom, I've played with a bit of polishing and sanding it. You can cut it, like the threads have been cut with a tap and die. It's real stainless steel. Like it's wild that you can do that. And so I can't do that in my office. I don't have the, $500,000 printer, but you can order online.
Yeah, doesn't sound like an Officeworks job.
No, not yet. Maybe in 10, 15, 20 years, it might be something where, those printers that they use at Officeworks are, they were a wildly expensive technology back 30 years ago or whatever. But it's just been incredible that I can, iterate on a design, put it out in plastic maybe 5, 10 times, tinker with it, see what's not working, and then go, okay, let's do it in steel and see how it looks, see how it works. And it's worked really well for us. So it's been a journey.
Very cool. So looking at your prototype and your box, it's got bolts. It's not glued shut. So there is the possibility of somebody opening it up. Talk to me about the right to repair and keeping that. Yeah, it has a key.
Yeah,
it's not a sealed box.
Yeah, absolutely. Look, it's that balance of like if you seal it up, you're not going to get water in there if you glue it shut. But then you do have to get in there sometimes to do things to it. So there's a really interesting balance that you need to find. From our perspective, we want to be able to get in there and open it up and service it. There are times, and lithium-ion batteries are a good example of that, where you've got a highly volatile material and you don't know that the user knows anything about that technology, and you don't want them necessarily to be able to just sort of open it up and flick batteries around like I tend to, and possibly create a fire or a hazard for themselves. So it's a really careful balance, I guess. I'm a big fan of Right to Repair, and I've sort of watched is it Kyle Werns from iFixit? Are you across his work? So iFixit sort of started, it's got the I because it sort of started with pulling apart Apple devices, and they started giving them repairability scores. And this guy he either came up with or has been the biggest champion of the Right to Repair movement. And it's the idea that, if you buy a device and you own it, then you should be able to repair it yourself if you have the knowledge and the know-how and the will. And he's had a lot of success in, I guess, bringing Apple to the table. They've been a big thing with John Deere, which is sort of relative to the agricultural technology side of things, that, somebody who is running a tractor on a farm expects 30, 40 years out of their tractor potentially, and, they may be very rural. They want to just keep it going themselves. And the newer tractors were, maybe for good reason, maybe not, I'm not sure, but they were being locked in different ways with software and, all sorts of things that the right to repair movement is sort of saying, well, no, you need to leave these devices open so that if the user does want to get in and do something, they can. So we've always designed our devices with that in mind and have wanted to leave the user able to potentially open them up. What we've found is really interesting, and maybe we get into a bit of the lithium-ion battery stuff, but as a company, the risk to my company is that the user hurts themselves. And so all the legislation is sort of set up to protect the user, as it should. And so there hasn't been, I guess, from a legislative perspective, there hasn't been an environmental or a circular economy sort of lens put on that legislation. So everything sort of bumps me towards sealing up the unit. Everything bumps me towards making it more disposable. And we've really been pushing the limits even of, sort of looking into, well, how could that change or how could we adapt it? And we've provided some recommendations up through SV, through the project that SV is Sustainability Victoria. I'm getting better. One day, we'll get it right. Provided recommendations to them about, how product stewardship could look and how the rules, which don't technically prevent a user from getting into a battery pack, say, but how it could be clearer for the companies whether it is okay to actually make a battery pack user serviceable or not, from getting into the cells and pulling them out themselves. So there's a lot of sort of murkiness, I guess, around that probably still needs to be sorted out.
I remember back in our community radio days when I was maintaining radio studios to become an authorized service technician for, I think it was a CD player back in the day, because their parent company also looked after washing machines. I was going to have to be an authorized washing machine repair person, which felt pretty ridiculous for cleaning the lens on a CD laser. Yeah. Anyway,
absolutely.
So you're going to get into washing machines as well. That's the question.
We could look at washing machines.
Got the IP rating.
Yeah.
So you run a pilot with the City of Greater Geelong. What were you testing there?
So the pilot itself was the testing the device once we'd sort of gone through the process with them, and they've been super supportive of everything we've been doing for them. We started with them. Can we go back to green organics and like your green bin? Do you have green bins in Sunshine?
We do, yes.
You got green bins, right? Are you doing FOGO yet? The food and organic waste together?
It goes in the same bin, yeah.
Goes in the same bin, right. So in Geelong, they're trialling the food organics the food in with the organics as well. But back in 2018, 2019, when we started working with them, they were setting up a site just to look after the GO, which is the garden organics, and food wasn't really on the table at that time. But they were setting up quite an innovative site where they process that material themselves. A lot of councils, they pick up the material. So this is, your sticks, your grass clippings, all of that goes into the green bin, goes into a truck, probably a diesel truck, might get driven 400 kilometres out to, regional Vic or something like that, and gets processed out there. So they had decided we're going to do it in-house. So they set up a site out in Anarchy. That site is licensed for 35,000 tonnes of material each year. And the brilliant thing about that project was it was a blank slate. So many of these sites, they've been running for a real long time, and they've got amorphous blob A here and amorphous blob B here. And they've sort of got paper processes and, there's a couple of spreadsheets and whatever. And I'm sure they're all complying, but there's not no opportunity, but it's very hard to transition those processes because they're so embedded in what they do. So to get on the ground floor with the city of Greater Geelong and go, okay, we could work on all your processes right from the get-go, and we could all design it perfectly as a cloud-based system, and weren't even thinking about this, but in a pandemic where you're limited in how many people can be on site, it'd be really handy if it was all cloud-based. And so we built this system for them. So that, in its sense, was a bit of a pilot in that it hadn't been done in the organics industry itself. And so that software sort of takes into account, so the trucks come on site, they drop their material. That material has to be allocated to a batch. It's in a certain location, and then they track those temperatures. And then once it's been through that pasteurization process that I mentioned earlier, it can move on to the stockpiling. And so it was through that process that we got to that question of like, well, how do we actually monitor these temperatures remotely? Because we're in the middle of nowhere. We don't have, that access to internet, et cetera, et cetera. And that's where the pilot with them to actually test these devices and test whether they were useful, whether they were viable for what they needed came about. And so in the time we've been working with them, I don't have the exact figures, but we passed something like 300,000 records out of the devices from their system, or from their site. And, the EPA requirements for measuring and monitoring are sort of like for every windrow, and a windrow is just a big row, say of about 100 metres. So for every 100 metres, you just need one temp, three temperatures across that 100 metres once a day. But that doesn't give you a really good insight into what's really going on, and it's not going to help you if after that temperature is taken, the temperature starts ramping. So to have 300,000 records over a few years has been just it's incredibly valuable trove of data, and get a lot of great insights out of it.
So for a site like that, how many units would they have?
Well, because the way they work, they still do manual temp checking in their pasteurization sections, and part of that is because they need to be engaged in that part of the process because of some of the contamination that comes in. So you'll do a pasteurization of one row, and then part of the process is you need to run a machine through, which is called a turner. It's a big machine that actually sort of moves over the windrow and then turns the material inside out, essentially, because the heat's on the inside. So you've got to bring the outside to the inside so that then you can pasteurize it again. So they do that 3 times. And in that process of turning, you expose, little bits of plastic and bits and pieces. So they walk up and down. But their stockpile section is in what they call the northern yard. And out there, they can have anything from, 5 or 10 of these piles. So they keep 10 on site, and they move them around as they need them. We often see them because of the way the software works. It gives you the GPS location, and it's sort of like, on the 11th of June, there was one sitting in that bush there, and it's like, they pulled that out and left it on, and it was in the corner there. So sort of funny. It's like, it's only 20 degrees. That one's they're not relevant. But you see the material move around a lot because there's a lot moving in, there's a lot moving out, depending on what's going on the site.
And are there units like this anywhere else in the world?
There are other things out there. What we found in 2019 when we were first looking into it is there were a lot of sort of stationary weather station type devices, not necessarily very portable, lightweight, and a lot of them need sort of professional setup. So over time, there's more and more things coming up, and we always talk about how we're going to scale up and how fast we're going to scale up and what's the competition doing and all of that. We think we've got being a stainless steel box. We think we've got the toughest solution, and they do get knocked around on site, but also kind of keeping it to 4G. and sort of not looking at the other technology. So there's, lots of connectivity options. There's sort of LoRaWAN is one of them. Wi-Fi is an obvious one that everyone uses, but you start getting into questions of like, well, if it's a sealed box and you don't have a keyboard, like how do you type in your details and that sort of thing? So we've really focused on just making it the easiest to use, that you go, you take it out, you point it roughly in the direction that the sun's most shining during the day, put it in, press that one button, and then go back to your software and your data should turn up.
Yeah, the one button push is very easy to work with.
Yeah.
So what are the users saying about the system?
Look, I mean, they all love it. It's probably the part that I love most, especially working with the local clients, is being able to go and see them and kind of the joy that it sparks in them. They've kind of explained that the sites that they're at, they're quite remote. It can be like when it's windy, it's real dusty and it's a really hard environment to be in. So they're always sort of excited to see us because we bring out the new toys and, hey, we're working on this and, it's really interesting for them. But then it's so valuable for them to be able to come back to us and they know that they can give us feedback. So, and that's led to that sort of third version, really trying to get it right this time. So the first one that we built, which was sort of pre-Rhino Instruments, it was top heavy. So it was like you'd put it in and then the wind would blow or the rain would come and the solar panel would end up pointing south to the ground. And so, obviously they put a bollard, or some sort of staking system, but that was obviously a design flaw that we needed to work on. Also went sort of too simple with that first version. It just had one sort of toggle switch on it and one LED green light. And the feedback eventually was that, this is almost too simple. We don't know what it's doing when that light comes on. Is it working? Does it have connectivity, et cetera, et cetera? And that's when we moved to that sort of always on screen idea. So yeah, getting that back and really understanding what the user needs has been really important to me. And I guess that's why they like it, because it keeps moving with them, which is good.
And the always on screen, that's what kind of display is that?
So that is a sharp memory LCD. So it is an LCD screen, liquid crystal display, Sam. But it has sort of e-ink qualities to it, which is the stuff that you see on the Kindles and that sort of thing. So funnily, being a lover of podcasts, I don't know if you know the Playdate device. It's a little kind of Game Boy-esque yellow sort of bespoke game machine.
I'm going to have to listen to this podcast and look back at all the things that I don't know about. Yeah, tell me about the Playdate
I think
device.
it would have been like 2016 or 2018. One of my favorite podcasters who does it, sort of a technology podcast, he was mates with the guy that created the Playdate. And so he had him on the podcast and they were actually talking about their process of finding the right screen for their little Playdate device. And so we've got the same screen as them based on a random podcast episode that I heard. And he saw it in Japan on a coffee machine. So it's this, weird lineage.
Love it. So we've been talking about batteries throughout this process. And, with the magic of editing, we've got batteries in front of us now. So you've been tinkering with the idea of reusing old lithium batteries, haven't you?
Yeah.
Talk to me about that.
Another random story of being in lockdown and, my YouTube habits tend to be looking at people as they pull apart electronics and do different bits and pieces. And obviously we'd had some experience with battery technology, building the first two versions of the device. And I was seeing sort of this sort of growing trend of people going, my vacuum cleaner battery, has stopped working. So I cracked it open with a rock and I've pulled the enclosure out and I tested the batteries inside, or the cells inside, the individual cells. And I found that only one was no good. So I've I pulled that out and I put a new one in. Look, I'm back up and running again. And with what I know or knew at the time about batteries, I'm like, oh, that's not a great idea. Just replacing one. They're meant to be balanced. So I'm watching these videos going, oh, that guy hasn't published in 6 months. He might have burned his house down. And but it sort of gave me this idea that like there is this there's room to do some research in this field, because also being involved in the waste space, I've had involvement with the other areas of and not just organics, the transfer stations and that. And, lithium-ion batteries are kind of our, in some senses, our climate savior, right? But they're also, they're piling up and we don't have the infrastructure to properly recycle them yet. And there's things happening in Europe, but here, lead acid batteries, which are the type that, you typically have in your car. That's probably the one that's most known, 100, maybe 200 year, it's probably 150-year-old technology. And, it's 99% recyclable and 99% of it is recycled. And that's fantastic as a, for a technology to have that much recyclability is great. Lithium-ion batteries are also in that range of 90 to 99% recyclable, but only 10% in Australia, according to the CSIRO, is recycled in one of the reports that they did in the early sort of 2020, 2021. Maybe that's changed a little, but probably not a lot. And what I had seen is that the EV cell recycling had been getting some traction. And probably the reason for that is that, take one of the early Teslas, they had the same batteries that are on the bench here, which are called an 18650. Well, interestingly, I just learned this is size A. So you've got AAA and AA, everyone knows those. The 18650, which for those who are watching is one of these, is size A. So when you've got 7,000 of them in one vehicle, it makes sense that you dismantle it and you pull it out, and out of the 7,000, maybe there's 6,000 or 5,000 that are still useful. That's a really good, easy to reclaim resource. But then there's piles of these consumer batteries that are being discarded, and they're a lot harder to get into, and it's not clear whether you can reuse those cells. So there was a markets sort of grant with Sustainability Victoria that was available for sort of e-waste and, looking at ways to reuse things, recycle things, new technologies. Some of the funding went to I know you've been working with Deakin, they've done a lot of work in like solar panels, and, there's a massive solar panel waste issue at the moment that's slowly being solved. How do we actually grind it up, separate the glass, take out the silicon, and remanufacture that into something. And with lithium-ion batteries, that's an area of research as well. I don't, on the actual physical recycling, that's not something I can contribute to, but I was looking at it from the perspective of from a circular economy perspective, reuse. If we're seeing in these YouTube videos that maybe, if you've got a bank of 8 cells and only 1 or 2 need to be replaced, that means that, there's a handful of cells in there that are still good. What is the actual number of cells that are good? So we got 50 of these from the local transfer station. So all different brands, I'm holding one from a common vacuum cleaner maker, but, we're all using these things. We're all buying them. There were Ryobis, Makitas, all the different ones, all the drills, all of these packs. We pulled apart 50, and when you open them up, they look more like this. And to just describe that, there's an external shell, and then when you get to the internal shell, you have maybe 5, 6, 7, 8 cells, which are individual cells that are strung together, and this is the 18650 that I was talking about. And so from 50 battery packs we pulled apart, we pulled 200 cells that we deemed testable. So, when you pick these up, like some of them, as soon as you sort of start to open them or undo the screws, it's clear that there's water damage and you kind of don't want to touch that stuff. But of the ones that we opened up, we found 200 cells, and then we tested those in a commercial tester, and we found that 59.4% of them were still in a serviceable condition. And we marked serviceable as above 80% capacity. Arguably, they can still be used below 80%, but then they do start to fall away pretty quickly. So, but we were getting cells that were registering as above 90. Some were registering as like above the capacity that they state on the, because it's an analog technology in there. So some of the cells were actually in so fantastic condition you could basically class them as new. So that was sort of one part of the project, was going, okay, let's sort of validate that there are usable cells, and then let's try to actually use them together and see how we go with that. And that's where we got into the other output from the grant, which was this little design here. So this is a battery management system that can handle mixed capacity cells. And the challenge with reusing battery cells is that they've all got they all want to be their own special flower at a certain voltage, and they've all got their ability to give a certain amount of power out of each cell. And so when you put them together, they sort of start to fight, and they're like, no, I want to give this much power. And the other one's like, well, no, I've only got this much energy to give, I'm sorry. And if you've got a really strong battery and a really weak battery and they're sitting next to each other, the strong one will sort of take over and force the weak cell to give up too much power. And that's when you get to that state where the battery then starts to heat up and can get into a thermal runaway state. So, and that can be in discharge or in charging. But so they're a very volatile product that have to be treated very carefully. And so I guess that was the other interest, is like, seeing people on YouTube sort of playing with them and going, like, it's good that you're tinkering. You have the right to repair, and you should tinker if you know what you're doing, but you got to know what you're doing. And worrying about that kind of, you shouldn't put a single cell in with 5 other weak cells. So doing this was kind of a way of formally showing with Sustainability Victoria that there is a pathway to do this. And the way that we did that was with a series of battery management system, like chips, which the way they're configured is that each cell doesn't really know the other one is there, so they don't affect each other so much. And so the way we've sort of approached this is, well, we make a low current device. These are coming out of high current devices. So, using a portable, like a power drill, something like that, you need those batteries giving a lot of power. And that's why they're strung together in the way they are and don't have intermediating electronics. But my idea was, okay, well, can we actually look at, can we reuse these cells that are still perfectly serviceable, but not necessarily in a high drain environment? Can we move them into a low drain environment, like a little, a temperature logging device or an environmental monitor, which, it just ebbs and flows. During the day, the sun comes in, fills up the battery. At night, it measures. There is no sun, so the battery depletes a little, but it's not doing a lot. And so that was kind of the proof of concept that we wanted to get to, and a bit of my motivation as well for exploring this as a way of learning about battery technology and how we could incorporate it into our device in a clean way. And the cool thing, one thing that's come out of it is that because of that regulatory side of things, we have to be confident using second life batteries. And right at this stage, I'm not sure necessarily that we are confident doing that, just because, we get battery statistics back and all that. So we can run test devices, we can do another year of data collection and see how they all interact and all of that. So we're taking our time there. But in the meantime, even if we're using new cells, we put 2 new cells in our device, we can be confident that they're going to get spent to the fullest amount, and that we're not creating unnecessary waste from cells that are not, not being spent just because one went bad. So there's been a few benefits to that.
When I was a kid, I was pulling apart my remote control car, and my mum walked in and she said, "Do you know how to put that back together?" And I went, "Yeah," didn't,
No.
and never did. Were you the kind of kid that was able to put it back together?
Eventually. But yeah, apparently it drove my folks nuts. The dad would always talk about, yeah, all I wanted to do was pull apart everything and just sort of look at it and that sort of thing. So, yeah, for a while I just broke every toy I had, and then eventually, yeah, started fixing them. Eventually was fixing other people's VCRs for them and that sort of thing. But yeah, you have to break a lot of stuff first.
Can't make an omelette without breaking a few eggs, hey?
That's true. That's true.
So what design lessons did you learn from taking other devices apart?
I'll start with the ones in front of me.
Sure.
But it was really interesting. This is where I can talk about Dyson, because I'm holding Dyson battery packs, and like I said earlier, I don't want to pick on any one company because there is reasons for this. But one thing that we found really interesting that we noticed while we were pulling apart packs is that this is an earlier version of one of the vacuum cleaner batteries, and this is a later version. And they've got better about making their, I guess, end of life stewardship is what it is. And in this pack, we couldn't get those two central cells out because there's a little bit of looks like thermal glue in the center and maybe a temperature sensor to, probably to make sure that, when you're charging, that the cells are at a good state. And that would have gone into the battery management system of that battery. But yeah, we can't, those two cells probably okay, but we can't actually get them out. In the later version, we've noticed that there is a sort of, they're still difficult to get into for good reason. Don't want everyone getting in, but once you do get in, there's an unclippable sort of lid, and then you can slide the batteries out once you've taken the tabs off. So, yeah, I mean, that's sort of what
I've been watching you slide the batteries in and out, and that's very easy.
Yeah, it's really cool. And so, they're obviously, I think, probably one of the things that's driving them, apart from, they have their own sustainability goals and that, but the EU is, some of the lawmaking there is that, you have to make your products, you have to think about the end of life for them. So that's been really good. But yeah, I mean, opening up everything has been really fun because you just like you'll notice little changes between versions, or I had I guess the whole waste thing is probably it's a good thread that I've always had. I would as a kid I'm guessing it's the early 90s, I'd walk to school or walk the streets of Sunshine and be seeing, they used to just do the waste collections where you put your hard rubbish on the lawn, and it would just be like be a gold mine of just amazing stuff everywhere. And I just could not understand why all these old computers were being thrown out on the lawn. They were, perfectly good as far as I could tell. As a kid, I wasn't sort of aware of the greater context that, computing was moving really quickly and processors were doubling in speed every year and all that. So I'm finding, Amstrads and Apple IIs and, all these computers that have different they're all bespoke at that time. Some had tape drives and, we're talking about zip disks earlier, all this amazing technology. So just sort of opening them up and looking at the different bits and pieces. And one of the computers that I had was one of the early Macintoshes. You've got one out in the background there. So I remember I didn't have the tool. It was a torque screw, which were not very common at the time. So I didn't have the tool to get this thing open. So I ended up sort of pretty sure I kind of cut the case and, anyway, I got in there eventually. But when you open up the back shell, it's got a bunch of signatures on the back, and it's all the people that worked on the Macintosh. And like, no one's meant to see that. So to like discover that as a kid, I was just like, what went on here, and later the internet came along and you can search these things. And it was a thing that, that company did in sort of the early 80s. And I think one of the reasons they possibly stopped just listening to a lot of bits of material on it is that there's just so many people involved that you start to have to pick and choose who goes on the case, which is not necessarily so fun. But I just distinctly remember discovering that and just kind of going, That's really interesting, and getting a sense of like there are individual people behind this product as well.
It's not magic.
Yeah, really, really cool. So open your products is my advice.
Not all products.
Not all products.
Ascent Media will not be held responsible for any damage caused.
Nor Rhino Instruments or Sequence Digital.
What surprised you most on your journey through all of this?
What surprised me? Life's full of surprises. I don't think I saw myself doing all of this.
Especially coming from, your media background, it's a big jump.
Yeah, it's been, I guess so. Curiosity and where curiosity takes you is a surprise. I guess a lot of this is a surprise from a surprise outcome from lockdown. That some of our traditional work dried up, and I had the freedom to I'd always tinkered with electronics, but we had this opportunity. We're talking to them. They're asking me about it. And I'm like, you know what? I can invest time in this right now. So I guess that's been really surprising. Yeah.
What's been the hardest part? Tech, funding, or adoption?
Oh, that is a good question. Adoption is not a problem. I reckon it's like I've had the mind for I need to do a circuit board, so I'll hop on YouTube and learn what software people use and how to use it, and I'm going to start playing with 3D printing. I'll start playing with CAD software and start printing and that sort of thing. I think it's the learning how to design something for manufacturability and the complexities of scaling a business it's really tough. We're still working through that. So, we're working with a so far unannounced business manager who is doing a lot of good work for us. But really thinking through it's one thing to create 1 or 3 or 5 of these devices, but when you have to think about you're going to have to make 100 of them, but also because of the regulatory framework around that and the compliance work that you have to do, you don't want to change your product once you've made it. So, even if you think there's a chance that you might make more than 100 of them, or you might have to hand them over to a contract manufacturer, you have to start thinking about how you would manufacture it so that somebody else could do it. And that starts to get really complicated. And that goes back to these 2 battery packs. I don't for them to glue in 2 cells, there were probably constraints in the factory, with how you could make it and how you could get that sensor in. And over time, once they're out of the gate with a battery vacuum cleaner, then they could turn an eye to improving the process. So much goes on in there to get from A to B. Yeah.
Who's helped or inspired you along the way?
Oh, a lot of people. Thinking about this, actually listening to the other episodes, and I got to say, yourself being in business, it's a unique thing. Most people they work jobs and they've got the security and all of that. And out of school, my uncle, great name, my Uncle Sam, he said to me, look,
is he a Salvatore?
He is a Salvatore.
Oh,
yeah.
Awesome.
You're a Salvatore.
When I found out that Salvatore was shortened to Sam, I was like, well, from now on, if anybody asks if Sam's short for Samuel, I'll say, no, it's short for Salvatore.
Salvatore, yeah. I believe he's a Salvatore. I should check that.
Anyway, so Uncle Sam, yes.
Uncle Sam. We knew him as Uncle Sam. So, yeah, he said to me, look, you're finishing up school. Come in, you can work at the factory. And he was they did cabinet making, so, kitchen cabinets, that sort of thing in residential. And, most of my friends were out doing schoolies and whatever, and I've sort of turned up to the factory to, just sort of start doing cabinetry. And I found that time really valuable, I guess. But what I enjoyed most about it was sort of seeing him do his thing in his space. because, he is Maltese migrant, would have come out in, the 1940s or 1950s, post sort of Second World War. Probably didn't have a lot of means and that sort of thing, but he'd built up to the point where he had his own factory. And I watched him be a master of his own time and his own, sort of being able to follow his own passion, which I really enjoyed. They were doing cabinet making, but he was actually a craftsman. You could give him a block of wood and a chisel and he'd make something beautiful out of it. So you'd see that through the work and, come over and look at what you were doing. And, I was working on the edging on, internal of cabinets, but still he didn't file that very well, So I didn't last in that job. It was very it's hard work, and I saw him work really hard, but then I also saw him, have some projects on the side and, if he wanted to, he could go out and, do some quoting and that sort of thing and then come back. And it was a real, obviously I was a blood relative, but, even just the staff that he had there that weren't related, it was a real sort of family environment. And I don't know, I found that really cool. And, we've got our little workshop now and I'm sort of emulating that in a sense that I don't think until then I'd really realised how fun it could be being in a small business and sort of being master of your own time and following different directions and that. So, I mean, you must feel this yourself, right?
Yeah, very much so. Are your kids interested in what you're doing?
They're super interested. I thought every kid wanted to tinker and pull things apart, and I learned pretty quickly that that's probably not the case. But it's great being able to bring them in, and they're at the workshop. Some of the stuff that we've designed, especially with my daughter, she's 9, so she was around when I was doing some of the earlier designs because I spent a lot of the time in lockdown with her. So she's sort of seen the process of the whole thing happen, and the device gets smaller and all that. So she's got an interest in it. I don't know how it'll affect her or what they get up to, but they're definitely they're into it.
Yeah, my boy is he's only 3, so it's very early days. But the way the film and photography industry is going, I don't think I'll be handing. Yeah, I don't think it's going to become O'Reilly and Son. I don't think the industry will be the same at all when my boy is old and working. Much to my disappointment, I'd love to be on a shoot with him. Yeah, but I will be very old by that point. What's coming up for you?
I guess I hinted at it a bit, the scaling part, trying to get a bit bigger. So, at the moment it's 3 of us. We've gone through the hard work of making the product to a point where it is more manufacturable. And we're starting to look at partnerships with, consultancies that actually go out and do remediation work and that sort of thing and grow in the organics industry a little bit more. So it's learning that side of business, I guess, which, unless I guess you've done a master's and sort of gone through that, that's not necessarily my bag, but there are people that can help you with that. So that's the area we're going into, hopefully.
And where can people learn more about what you do?
So if you want to, I guess, see me on social media, I'm probably most active on LinkedIn professionally. That's probably the place. If you watch the podcast, connect, put a message in, say I heard the podcast. We'll talk. Otherwise, rhinoinstruments.com.au is the website. There's a contact form there that goes to all of us anyway, so you can get in touch there.
Beautiful.
Yeah.
Now, Pat, after 30 plus years since you were in this building last, I couldn't let you leave without a thank you. Here's
no way.
A bag of mixed lollies.
Oh, thank you. Wow. Well, the ring. Used to love the rings.
The ring, yep. And there's some Coke bottles in there as well.
See if do they still fit on the finger? Just on the pinky. Yes, thank you, Sam. That's very nice of you. I'm going to enjoy those on the ride home.
Excellent. Well, Pat Blampied, thank you very much for coming on to Ascend Your Story.
Thanks for having me, Sam.
Thanks to the Ascent Media team for putting the show together. Producer Jonathan Brown, all things production Michael Nguyen, and intro sequence by Nico Scott. I'm Sam O'Reilly. Ascend Your Story is an Ascent Media production. We tell the stories of amazing people in science, tech, research, and more through video, photography, live streaming, and podcasts like this one. You can see our work and check out all the other episodes at ascentmedia.com.au.